Hey guys, in this video, we're going to talk about bivariate data. So far, the data that we looked at had only one variable. For example, we have students and we recorded their heights, just one variable. Now, the data that looks at two variables for one item simultaneously is called the bivariate data. So, for example, we have a data for cars that are sold on eBay, and for each car, for single car, we're gonna record its mileage and price. So two variables. That's bivariable variate data. Bi stands for two. Like if we have more than two, we could call it multivariable data, but for now we're gonna stay with bivariate data. Okay, so um, for each car in question, we record the mileage and price. Now, what can we do? So this is an example of the data table. And how do we present that data visually? Well, we can create a scatter plot with this data. And usually what we're gonna do, we're gonna again create an X and Y coordinate system. And for X, we will take a independent variable. And for the Y value, we're gonna take a dependent variable. So here we have mileage and we have price. So let's think about which one is dependent, which one is independent variable. Does price depend on the mileage, or does the mileage depend on the price? I would say that the price is dictated by the mileage. There are other factors that we're not looking at right now. That's going to be in the multivariate data analysis, but for now, we're just looking at the mileage as one variable. And so the price depends on mileage. So we're going to make mileage as our X value, and the price is going to be the Y value. And so we're going to ask StatCrunch to draw this scatter plot for us. So we're going to go to graphs, and scatter plot is down here. And it's going to ask us what are we going to select for the X variable? Well, mileage. For the Y variable, price. All right, and we're gonna hit compute, and this is the scatter plot that we got. So usually what we're gonna do later in this course, we're gonna look at the scatter plot and see if we notice any patterns, like so is the data linear, is, or is the line goes down or the line goes up, that sort of thing, how strong an association is. In other words, does our data points line up perfectly, or is it all over the place? We're going to look at all of that later. For now, I just want you to know what the scatter plot is. So we graphed our mileage in thousands on the x-axis, and the corresponding price in thousands on the y-axis. And I want to show you one more bivariate data set that I've collected. And this is from my previous stat class. I picked homework scores and the finals class scores for my students. And I just wanted to look at whether there is a correlation between the homework score and the final score. Let's figure out. What do you think? What would be your prediction? There's a lot of data values here. You cannot see everything, but I have well, a lot, 34 data values. And again, let's choose the deep independent variable and dependent variable. I will choose my homework score as independent. And okay, homework score independent, and final score is dependent variable. Let's see what we get. Look at this correlation. Okay, there are some points that are off. Like, for example, this person, um, he still didn't pass the class, but his homework score was around less than 20, but his final score actually got slightly above, no, below 40, actually 39.28. So, but the rest, look at, you know, basically the people who did well on the homework score, they also did well on the final score. So that's one thing that we can get out of the scatter plot to see if there is a correlation visually. Then later in this class, we're going to actually analyze it numerically. We have methods for analyzing this kind of correlation and see if it really is strong enough or not. We're going to discuss all of this in this class. All right, we have one more scatter plot called time series. This is another type of a scatter plot, and that's a type of a scatter plot where for the independent variable we have time. It could be years, it could be days of the year, it could be months of the year, and then we have one value per each x value for each time stamp. Okay, and then that scatter plot. So our time will be our independent variable. It's going to be x, and our whatever we're measuring is going to be our y value. Okay, so here's an example of a time plot or time series plot, and this is for global mean temperatures, temperature differences from 1850 to 1900. So I think so we see that this data goes beyond 2000 up to 2022, and it says that the year 2020, it says the World Meteorological Society reported that 2020 was one of 3 warmest years on record. Okay, so what's going on? What's up with 1850 and 1900? So I think what they did, they basically took the mean temperature, they calculated the average temperature for those 50 years, and then they later they compared in all the consecutive years, they've compared those values with the temperature, the average temperature from year 1850 to 1900. So if it was below that average value, the average temperature for the given year, then they recorded it as a negative. But it was above, then they recorded as a positive change. Okay, so and as we can see, so basically they took the average for this period right there. But then as you can see, the temperature was increasing all the time. Like it went down a little bit between 1950 and 1975 roughly, and then it kept on going up and up and up. So this is an example of a time series or time scatter plot. All right, now let's talk about another type. of bivariate data, or another way to organize and present bivariate data, which is called a contingency table. And basically, those tables are used for non-numeric data, usually for qualitative data. So here again, we have, this is our data. We have cars 1 through 5, and then for each car, we record the color of the car and the condition. And the color, of course, we just broke down as light and dark. It could be more detailed. We could write all the colors of the rainbow. We need a bigger data set for it, because I think if we did it with 5 cars, each color would be unique, which is not what we want for the demonstration purposes here. But anyway, so here we have colors like light and dark, and we have also conditions like new and used. Okay, so each car is labeled as dark or light, or like new or used. Now, how can we organize this data? So if we have only 2 variables, then we're gonna organize one variable in as a column and another variable as a row. Excuse me, doing something. All right, here we go. I had a animated slide for it. Okay, so here's our data, and when we organize it, we put color in one column, so we have light and dark, and then we have another variable condition of in the row. So, and basically, and then we've put in the frequency in each cell. So this cell, for example, if we look up, it has condition like new, and if we look over, the color is light. So that means that we have one car that's light and like new. And then when we look at this value 2, we look up, we see that it says used, and then we look to the left and it says dark. So that means we have 2 cars that are dark color and used. Okay, so that's how you read these tables. These are kind of frequency tables, and we're gonna discuss that in the next slide. What else we usually do with these tables? We add totals, and they're called marginal totals. So we have column totals, and we also have row totals. So we have a total of 2 cars that are like new, we have 3 cars that are used, and we have 5 cars in total. So for the colors, same thing. We have 2 cars that are light and 3 cars that are dark, and in total 5 again. So this cell, so the 2 and 3 are called row totals, and this 2 and 3 are called column totals. Now here 5 is a grand total. So notice that we don't duplicate it. We don't add 2 and 3 and then in row totals and then 2 and 3 in column totals. We would have 10, right? We don't do that. We either count the column totals or the row totals, not both. Okay, and they all should add up to the total number of the items in the table. All right. Now let's talk about, so those tables are also called the two-way frequency tables. And the reason is because you can read frequencies from these tables. So if we, for example, cover the one of the variables, which is car colors, we covered it up. We ended up with just frequencies for the condition. We have 2 like new and 3 used cars, a total of 5. And if in turn we cover the condition, we end up with a frequency table for the colors like this. And this is it for this video. In the next video, we're going to talk about graphs that are designed not to give you information, but mislead.